Hi everybody. We're going to wrap up chapter 5 by learning one more technique for integration that's called integration by parts. Integration by parts is mostly used when inside your integral you have a product of two functions. Remember, the integral of f times g is not the integral of f times the integral of g. Sometimes we can use u substitutions in this situation, but sometimes we can't. And it's when you can't use a u substitution, in other words, when none of the u substitutions will work, that's when you use integration by parts. The integration by parts formula says that if your integral is of the form u dv, then you can evaluate it by doing uv minus the integral of v du. And I know right now that makes no sense, so let me show you an example. We are going to find the integral of x ln of x dx. And this is one where you can try any u substitution you want, it's not going to work. So to use the integration by parts formula, we have to start out on the left-hand side and decide which part of our integral is going to be u and which part is going to be dv. The part we call dv is going to include the dx from the original integral. And then after that, we have some computations to do. We'll have to compute du and v to plug into our formula, right? Because our formula includes a v and a du. So suppose I try letting u be x and letting dv be ln of x dx. So this decision is where we start. Like we were just saying then, to plug into our formula, I need to know what v is. I've already decided on what u is, but I need to know what v is. And I'm going to need to know what du is. Du is no problem. If u is x, then du will just be dx. V, though, is trickier. V would be the integral of dv, which would be the integral of ln of x dx. And the problem is, we don't have a formula for this. In other words, we don't know the antiderivative of ln of x. That means we cannot use this choice of u and dv. We'd be stuck at this point. So we try again. Well, if u isn't going to be x, then the only other thing in the integral is the ln of x. So u would have to be that. Once you've decided what u is, dv has to be everything else. So in this case, dv would be x dx. Remember, the dv always includes the dx. Let's see if we can make progress now. If u is the ln of x, then du will be 1 over x dx. And if dv is x dx, then v would be the integral of x dx. And that we can do. That would be 1/2 x squared. Let's plug those into our integration by parts formula and see what we get. So our integral of x ln of x dx is going to turn into uv minus the integral of v du. And we just read those things off from our decision and computation here. U is the ln of x. V is 1/2 x squared. Then I have minus the integral of v, again v is 1/2 x squared, times du, and our du was 1/x dx. We're not stuck at this point, so let's keep going. Let me clean up this stuff that's sitting off to the front here. I'm going to write that as 1/2 x squared ln of x minus, and for the integral, that 1/2 can come out front, and I can do some simplifying too. The x in the denominator will cancel one of the x's in the x squared, leaving me just an x dx. That we can evaluate. So we'll have 1/2 x squared ln of x minus 1/2 times, and the integral of x is 1/2 x squared. And then I need a plus c because it's an indefinite integral. And there we go. We don't have any more integral signs in our problem. We're left with 1/2 x squared ln of x minus 1/4 x squared plus c. Now, these integration by parts problems are really tough, but remember, you can always check your antiderivative by differentiating. So if we're correct in saying that the indefinite integral of x ln of x is this stuff, then if I differentiate this stuff, I should get the x ln of x. Let's try it and make sure. To differentiate the 1/2 x squared ln of x, I need the product rule. So I'll have 1/2 times 2x times ln of x plus, and I'll have 1/2 x squared times the derivative of ln of x, which is 1/x, then minus, and the derivative of 1/4 x squared is 1/4 times 2x, and the derivative of c, well, c is a constant, so its derivative is 0. Let's simplify and see what we've got. In this first spot, the 2's cancel out, leaving me an x ln of x. Then in the next spot, the x in the denominator cancels one of the x's in the x squared, leaving me 1/2 x. Then I have a minus, and in the last spot, 1/4 times 2 is 1/2, so I've got a 1/2 x there, and yay, the 1/2 x's cancel each other out, leaving me just x ln of x. So we are correct in our antiderivative, or indefinite integral, for x ln of x.